Well, hello there. Today, we're going to summarize the work we've been doing on sampling distribution of sample means and sample proportions. We'll try to do it with a picture so that we can sort of put everything together. But let's start with what's going on. We have big N. Now, big N is a population. Now, in introductory statistics, we're going to be interested in really only two things about this population. Something quantifiable, the mean, and something categorical, a proportion or a percentage. For example, you might have a population of young adults and you want to know their average height. That would be a mean. With that same population of young adults, you might want to know how many like raspberry jam. That would be a proportion. And that's how this works. But we can't really ask a question to an entire population of subjects, right? So what we do is we pick out little n, which is a sample. Now, there are lots of questions about this sample, right? And that's what we're going to talk about as we keep going through this. But basically, what we want is a simple, random sample. How big is the sample? Well, we know that little n has to be less than or equal to 1/10 of big N. That's always going to be true regardless of what we talk about, means or proportions. Now, there's going to be a few more constraints on little n, but let's see what happens. Okay, so now, once we've satisfied that, we go one of two paths. I'm either going to go the proportion path, or I'm going to go the mean path. Okay, now the proportion path, this will be the proportion of successes. Now, a success is whatever you're trying to measure. How many people are left-handed? Or what proportion of people are left-handed? If you survey people, if they say yes to being left-handed, that's a success. The mean is the mean. Okay, so we estimate P, right, with P hat. P hat, this is the proportion in the sample. And again, we estimate mu with X bar. This is the mean of the sample. Now, what else can we calculate? Well, we can calculate a standard deviation for the sampling distribution. Now, what does that mean? Well, so what we're going to do is we're going to take a sample, but are we just going to do one sample? No. We're going to do lots of samples, right? And if we do that, right, what we're going to say is the mean of the sampling distribution should be the mean. Okay? That makes sense, right? If we did repeated samples of 50 students and measured their height, and then we took the average of all those averages, right? Here's the other thing that happens, though. The standard deviation of the sampling distribution is the standard deviation of the population divided by the square root of n. When we calculated this mean, generally in these introductory problems, we're also going to have a standard deviation. Same thing over here. We're going to take repeated proportions. And what should happen is that the mean of the sample proportions should end up being the true proportion of the population. The standard deviation of the sample proportions is going to be the square root of P1 minus P divided by n. Okay, so this is what's happening here. We're doing these repeated samples. Now, these formulas, you're generally going to be given these on every test, so you don't have to memorize them, but you do know how to use them. And how do we use them? What do we do with means and standard deviations? Sound familiar? Yeah, the normal curve. But how do we know this is normal? Funny you should ask. Okay, now we run two tests. Let's go over here first because this is the most straightforward. We simply run a test and we say NP greater than or equal to 10 and N1 minus P greater than or equal to 10. Now, what does that mean? Well, this means that is it even worth studying? We often say if you want to do the proportion of teenagers that get more than 10 hours of sleep, you're not going to have more than 10 in any sample. So don't even worry about it. Pick another proportion. As long as this is true, we use table A or normal CDF. How do we use it? Well, there's your sample mean, your sample standard deviation, and then whatever you're trying to find out, right? Okay, now, how about over here? Well, we have two tracks we can take here on this side. One, if N, big N, is normal, then the size of little n doesn't matter. It can be anything we want. But what if big N is not normal? Let's say the length of songs on your phone. They may not be normally distributed, right? You have a short little attention span. You have a lot of short songs and a few long songs, right? If N is not normal, then your little n has to be greater than or equal to 30. And as long as that's true, the sampling distribution of the sample means will be normal. I know, blows your mind, doesn't it? But it's like this. Let's use our length of songs on the iPhone example. Even though the lengths of songs are not normally distributed, right? You have a whole bunch of short ones and a few long ones. If you were to take simple random samples of those songs and then take the average of those samples, those results would be normally distributed. And what would the center of the distribution be? That mean. And as long as these two things are true, then we're back to table A in the normal CDF. Now, we've done a few examples in the previous videos, but this kind of ties together everything that we're doing. And that is how you deal with the distribution of the sample means in the sample proportions. Have fun and see you next time.